Welcome to my presentation. In this presentation, let us try to see how we can add two vectors. Let us take a simple example. In this example, let us say vector u is given to us as 2, 5 and vector v is given to us as 3, -3. What we want to find here is the sum of these two vectors, vector u plus vector v. We will not only do the simplification, but also we'll try to see how we can graph it. We'll draw a graph and visually see where that point, where the final, where the product of these two vectors is going to be. Okay. Let us get started. In here, vector u plus vector v. The v, according to the property, we're going to write the components down first. Plus vector v is 3, -3. The way we can do this one is we take the first component of the first vector, add it to the first component of the second vector, comma. We take the second component of the first vector and then add it to the second component of the second vector, which is a -3. So when we simplify that, 2 plus 3 is 5, 5 minus 3 is 2. So that the sum of vector u plus sum of vector v is going to be equal to 5, 2. Now that we have that information, let us see how we can graph it. Let's go to our graph sheet here, and let us say this is our graph and this is our origin here, and let's go 1, 2, 3, 4, 5 points on the y-axis, and let's say these are 1, 2, 3, 4, 5, 6, 7 points. If we need more points, we'll pick them up. 1, 2, 3, 4, 5, 6, 7. Since we do not have any negative numbers, I'm not going to pick any points on the negative x-axis or on the negative y-axis. Okay, so we want to represent first vector u, which is 2, 5. Let's go some more here, and then we can represent. This is -1, -2, -3, -4, and so on. The first point what we want to represent here is vector u, which is 2, 5. We're going to go 2 units on the positive x-axis and 5 units on the positive y-axis. So 1, 2, 3, 4, and 5. So this is the point we want to be. So this one here, it starts from the origin and then ends at that point. So this is a vector, and this is 2, 5. That is 2, 5, and this is vector u. This is vector u. Similarly, we can represent vector v. Vector v is 3, -3. We're going to travel 3 units on the positive x-axis and 3 units on the negative y-axis. 1, 2, 3. So this is where we want to be, and therefore we're going to draw a straight line from the origin to that point, and this is vector v now. Vector v now, and the terminal point here is 3, -3. 3, -3. This is vector u, and that is vector v, and we have seen the sum of vector u plus vector v is 5, 2. So now we want to represent that vector, which is going to be 5 units on the positive x-axis and 2 units on the positive y-axis. 1, 2. We're going to go 2 units up that way. Therefore, we're going to draw a line from the origin. That is the starting point, and that is the terminal point, and the components of the final vector are going to be 5, 2. 5, 2. This is 5 and that is 2. And this vector here is vector u plus vector v. This is the sum of vector u and vector v. And the way we can do this is we can join these points. And we can now see that the sum of these two vectors is going to be u plus v is going to be terminating at 5, 2, and that we can also call it as the resultant of these two vectors. So this is the way we can use the properties of vectors to be able to arrive at a solution, and also visually plot them out on a graph sheet to see how they look. In my next presentation, we shall look at some more examples using properties of vectors.